we have one more operation that we can do with functions, and this is probably one that's brand new to you. It's known as the composition of functions. Essentially what we're doing is we're taking a function, plugging it into another function to create a new function. I know that's the word function a lot. So there's two ways of writing this. The first is with the open circle. So f open circle g, which we read as f compose g. The other way how it is written, which is probably how most people like to write this and use, is f of g of x. So these are interchangeable, okay? So you have option 1. This is the formal notation. And then you've got f of g of x over here, which is the informal notation. So when you're looking at a textbook, let's say most of you go to like a 1050 class or a 1010 class, whichever one teaches the functions, you're probably going to see this notation here a little bit more than you'll see this notation right here, but they mean exactly the same thing. Now, the way how we approach the function composition, I'm going to rewrite this part right over here. Unlike our other functions where we go just from left to right in our operations, on composition we go from the inside to the outside. So we work inwards then outwards. So if we have f of g of a value, then we're going to do the inside first and the outside. That's the typical way of putting it. So let's look at an actual example where we have to get a general function. If these are our given functions of a of x and b of x, let's find b compose a of x. Now remember, this is the same thing as doing b of a of x. So first, let's find our a of x function. Well, our a of x function is 2x minus 3. So I'm going to rewrite this using my a of x function. So I have b of, and a of x we said was 2x minus 3, so I'm going to plug that in. So 2x minus 3. We're going to take this entire expression, because this is our input, and we're going to plug it into our b of x function right up here. So we end up with 5 times 2x minus 3 squared. Okay, we've seen this before, but let's do it one more time just so that we get that practice. When we have a binomial that has an exponent, that means there are two of them that are exactly the same. So we end up with 2x minus 3 times 2x minus 3. We'll worry about that 5 in a minute. We've done this before. Let's do it again. 2x times 2x, that gives me 4x squared. 2x times a negative 3 is a negative 6x. We have that again, negative 3 times 2x, that's a minus 6x. And then a negative 3 times a negative 3 gives me a positive 9. So when I combine my like terms here, I end up with 4x squared minus 12x plus 9. But I still have a 5 that I gotta remember to use. I gotta multiply that 5 through. So when I do that, I have 20x squared as the first term. 5 times a negative 12 is a negative 60x. Making sure that the variable's there. And then 9 times 5, which is 45. And we'll leave it like that. So no additional factoring, no additional anything, you just leave it as is.